The next thing we're going to look at is the probability of an event not occurring, which is also known as the complement. And sometimes I will use that, so just aware when I say complement, I mean the probability of an event that will not occur. Alright, so remember, all outcomes is 100%. 100% is represented by the number 1 in probability. 1 is equal to 100%. And so when we want to find the probability of event A not occurring, often it's easier to take 1 minus the probability of the event. Alright, so the probability of rolling heads is 1/2. The probability of not rolling heads, is rolling tails, is 1 minus 1/2, which also comes out 1/2. Alright, and so when we do the probability of an event not occurring, oftentimes, not always, I mean, the heads, tails example, it's not any harder to find it directly, or we're using this complementary equation. Right? But sometimes it is easier. For example, the probability of it raining today, 0.15, 15% chance. What's the chance it won't rain today? Well, it should make sense. The probability that it's not going to rain is 1, the probability of all outcomes, minus the probability it rains. So 1 minus 0.15 or 0.85. Right? If there's a 15% chance it's going to rain, it should make sense that there is a 85% chance it won't rain, right? The probability of not getting sick, so this time they're actually giving you the complement. The probability of not getting sick this semester is 90%. Find the probability of getting sick. Alright, so probability of not getting sick is 90%, or if you wrote the decimal, 0.9. I'm going to leave it as the percent, because it's just as easy to understand as a percent. And so the complement of not getting sick would be getting sick, and so it works the same way. Probability that they get sick would be 100% of the people, 100% minus the 90% who don't, and so that leaves the 10% who will, right? And so that's what we mean by using the complementary event. The probability of not getting sick is 10%. And then we can use it, since probabilities are predictors. That's what you use probabilities for. It's part of statistics to predict, what will happen. So suppose that we want to know the following. The probability of not getting sick this semester is 90%. If we observe 500 students, right, based on the probability, how many would you expect to get sick? Well, we know the probability they get sick from the previous one was 10%, or as a probability 0.1. Right? 10% of them we would expect to get sick, because 90% of them we would expect not to. And so what you do is saying you take your total times your percent as a decimal, right? We always multiply our percents times a decimal. So 10% would get sick, and that would be 50. 50 out of 500 we would expect to be sick, based on our probabilities, right? And if you take 50 divided by 500, that would come out to 0.1, which is our 10%, which means, they didn't ask it, but that means 450 would be expected to not get sick. All right, that would be the 90% who we would expect don't get sick. All right, next example. Suppose that we have a bag of M&Ms. All right, in the bag of M&Ms that we have 13 blue, 7 brown, 12 green, 9 orange, 7 red, and 8 yellow. All right, 1 M&M is chosen for it, so you're being very conscientious. You're just reaching in and grabbing 1. All right, not grabbing a handful. Handful would be a different problem. All right, you just reach in and you pull out 1 measly M&M. Find the probability of the following. So probability of blue, probability of green, and then the last one is the complementary set that we'll use our complementary for. All right, first of all, remember when we want to find probability, it's the event total divided by the total possible. All right, which we don't have the total possible. In order to figure out, when we reach in, the total possible will be, well, how many different M&Ms could I select? Alright, so I have to add up all the possible M&Ms that I could select. So we have to add all these up. Total possible would be the 13 blue, 7 brown, 12 green, 9 orange, 7 red, 8 yellow, and that adds up to be 56 total. There are 56 total M&Ms that you could pick. Alright, so 56 total. When you reach in, you're going to pull one of the 56 M&Ms out. Alright, so probability it's blue. Well, how many chances out of 56? Well, there are 13 chances out of 56 that you get a blue one. Alright, so again, you write that as the 0.232 or 23.2% chance. Probability it's green. Well, how many green chances out of 56? We've got 12. 12 out of 56, which if we write the reduced fraction, that's 3 out of 14. If we write it as the decimal, 0.214 or 21.4%. And it should be less than the previous answer, right? I have one fewer green marble than I do blue marble, so the probability for green and blue should be close. Blue should be bigger because I've got one more I can select from. All right, the last one is the complementary event, not yellow. What's the chance of not getting yellow? Well, the probability of not getting yellow is a little easier to figure out what's the probability of getting yellow, because it's easier to add that up because I have that. And so it's 1 minus the probability that you get yellow is a much easier way to solve this. And so 1 minus the chance of getting yellow, well, how many yellows do I have? I have 8 yellows, so 8 out of 56 would be the chance of getting yellow. We're sort of throwing that out, and what's left over? Well, what's left over is all of the other all the other M&Ms. And so, out of 56 M&Ms, if you take 1 minus 8 and you write the fraction, that's 48 out of 56. Right? If you add them up, there are 48 colors, not yellow. 48 out of 56, or the reduced fraction would be 6 out of 7, or the decimal 0.857, or 85.7%. All right, so like I said, sometimes it's easier to find, because it was easier to find out how many yellows I have, because they already told me, than to add up all of the ones that are not yellow. That would be the alternative. You could do that. If you added up all of the ones that are not yellow, that would be the 48. There should be 48 of them that are not yellow, and solved it that way. So again, the complement is just an easier, quicker method. When we get to bigger sets, you're definitely going to want to use the not method, the complement method. Now I'm going to stop there, pick up the next set of notes in the next video lesson.